Let's take a look at some of the physics application problems from chapter number 7. And for problem number 1, I have a particle that moves along a straight line, and I need to find the displacement and the distance traveled by the particle during the given interval. So my given interval is from 0 to 2 seconds. Okay, so at this stage of the course, I would just prefer students to set the integral and then use your graphing calculator to evaluate the integral. Okay, so let's find the displacement first. So if I want to find the displacement, the displacement is essentially the formula of the integral from a to b of v of t dt. Okay, and then your a value here is going to be 0, and your b value is going to be 2. All right, so let's go ahead and fill in those numbers. So my lower bound is 0, and my upper bound is 2. And what is my velocity function? My velocity function is it's going to be t squared minus 1, and then since the variable is in terms of t, I can write dt. All right, so there's your integral setup, and then from there, just go to your graphing calculator and put that in, and you should get an answer of 2/3. Okay, so that's how you would find the displacement for that first problem. All right, for the second question, I got to find the distance here. So the distance is equal to the integral from a to b of the absolute value of v of t dt. Okay, so if I had to go ahead and apply this to my problem here, remember I'm going from 0 to 2, so from 0 to 2. So to do that, I would just write in my lower bound, my upper bound, and then the absolute values here. And my function is going to be t squared minus 1, and then this is in terms of t, so dt. And then from there, just go to your graphing calculator, and you should get a final answer of 2. Okay, so that's it for that first question. Let's go ahead and do the same thing for question number 3. I need to find the displacement. All right, so displacement, I will write that as a letter D with a hat there. And that's the integral from a to b v of t dt. And my a value is 0, and my b value is 2. All right, so set the integral here from 0 to 2. And my velocity function is 4t cubed minus 4t, and then dt. And then go to your graphing calculator once again, and you should get a final answer of 8. Okay, and then if you want to find the total distance, I'll use letter D for distance here. That's the integral from a to b of the absolute value of v of t dt. All right, so let's go ahead and plug in our values again. This is going from 0 to 2 again. And now I need my absolute value of 4t cubed minus 4t absolute value, and then dt because everything is in terms of t. And then go to your graphing calculator for that as well, and you should get a total distance of 10 units. And that's it for the questions 1 and 3 to get the homework started. And then let's move on to the next questions here. For example number 2, the particle moves along a straight line. Find the position of the particle at time t. Okay, so if I want to find the position, I need to find s to t, right? All right, so there's a few ways you can do this, but if I'm given v of t, so the problem gives me a velocity function, right? So if I want to go back to my position function, I need to find the antiderivative. All right, so s of t is equal to the antiderivative of v of t dt. All right, so that's my strategy. I want to find the antiderivative of my velocity function, and that will take me back to my position function. Okay, so that's the idea. Let's go ahead and set this up now. So this is the integral, and my velocity function is 3t squared plus 2t, and this is in terms of t, so I need a dt here. And then let's go ahead and find the antiderivative here. So the 3 can stay in front, and then t squared is going to be t cubed divided by 3 plus 2, and then my t variable here, that's going to be t squared divided by 2, and then plus c. Okay, and after that, I would go ahead and simplify this if you can. So this is going to be t cubed plus t squared plus c. And then you want to use this fact here. We know that s of 0 is equal to 2, right? So let's go ahead and now factor this into the equation here. S of 0 equals to 2. So what that means is this is going to equal to 2 on the left-hand side. And anytime you see a t, that's going to be turned into a 0. So this is going to be like 0 cubed, 0 squared. So basically those will just cancel off, and we know that 2 would equal to c. Alright, so how do I finish this off? My final answer is I just go ahead and write my position function now. S of t is going to equal to basically all of this. So it's basically going to be all of this, which is t cubed plus t squared, and my value of c was 2, right? So sorry, that's a bit thick there, so plus 2. And that's my final answer for my position function there. Alright, so we're just taking the antiderivative of the functions that are given to us.